All right, so here we are with the composition of functions paper, and um, we're first given the definitions of here in number one functions f of x and g of x, and we're asked to evaluate g of f of x at a specific integer value, in this case -2. Now, in my experience, this is one of the composition of functions is one of. I guess it's time to change classes on a Saturday. All right. So, like I was saying, the way this is normally taught is just an abomination to mathematics, and I don't mean any ill will toward my colleagues. I'm sure that they're just trying to get the curriculum taught as quickly and easily as possible without too much frustration from the students. And so the worst thing that I see is, well, hang on a second. Here's the absolute worst thing I see. I see them bring the calculator out, and then they tell the kids, and that's just awful. They tell the kids, all right, put the equation in that you're going to have to evaluate. For example, f of x, okay? So they would tell the kids to type x squared minus 5x minus 7, okay? And then hit enter. And now they would have them look at the tables. So you hit second graph to look at the tables, and then go down to where x is -2. And then you find that y is 7, okay? And then plug in here, take this number here, go back to y equals, and type in 5x minus 13, okay? Again, enter, and then second graph, and what you're looking for there is where y is 7, or where x is 7, y on the g of x is 22. This is what they have the kids do, and it's disgusting. Okay, it teaches nothing, and this machine has absolutely no place at all in what we're about to do with this. Okay. So this should be pure mathematics without any need for a computation device. Okay, so let's actually do it the correct way. Let's compose the functions f of x and g of x. And it's asking us to compose g of f of x. So that means everywhere I'm going to take f of x and stick it here where this x is. So what I'm actually doing is I'm doing g of, and then in here I'm putting f of x. Like that. Okay? And that kind of encapsulates what we're accomplishing here, right? So what is f of x? Well, f of x is this quadratic. Okay? So that's equal to saying g of, and then putting in the whole quadratic like this, x squared minus 5x minus 7. Now, I'll explain why the calculator method it may be the quick and dirty way to get an answer, but why is it so wrong to do it that way? Okay, or why is it wrong to like evaluate the function f of x at -2 and then just stick the answer into x, and then for g of x, there we go. More interruptions. Okay. And there is a reason. It's because you never ever get the composed function. Okay, so you completely miss the point of the exercise, which is to compose the two functions. So anyway, now we're gonna go ahead and do this. So now everywhere I see in g of x, I have 5x minus 13. So where that x is, I'm going to replace it with this whole quadratic. Okay. So let's do some writing here. We'll say if g of x is equals 5x minus 13, okay, then g of f of x, given everything we've already learned about that above, equals 5 open parentheses x squared minus 5x minus 7, okay, minus 13. Okay, so we're composing these functions, you see, and now all we have to do is distribute this 5 here, here, and here. That doesn't look too bad, does it? Right, so let's see, that equals 5x squared minus 25x minus 35 minus 13. And this is what you miss. See, this is what you miss if you don't do this by hand. You miss this composed function. So let's simplify by combining these two, 35, 45, 46, 47, 48. So this is, let's keep our notation going here. G of f of x. All right, so G I'm going to use this notation now just so you can get the you can see the correspondence between the notation styles. The composition of G and F is equal to 5x squared minus 25x, and then negative 35 minus 13 is minus 48. And I can't simplify that. I mean, I might be able to factor the quadratic, right? But I can't just factor out a greatest common factor or anything. And so now we're ready to evaluate this, right? We're ready to evaluate the composed function at -2. Okay, so we will I'll use the same notation. Well, let me show it this way, just so it's super clear. So writing it like this, with this G and then this circle F of -2, okay, that is equivalent to writing it as G of F of -2. Okay, those are equivalent. So we're going to actually now evaluate that. We're using the composed function. This, I'm not going to put in a red box, but this is the composed function that you never see, and the students never, ever, ever see if all we do is break out the calculators. Okay? And so I just, it makes my blood boil to see that done. All right, so now we're going to plug in -2 everywhere we see that X. I'll just start by making a template for you. So we have -25 and then -2, and -2 goes in here, and then we have -48. Okay, so let's evaluate. So G, the composition of G and F at -2 equals -2 squared is 4. 4 times 5 is 20. 20. And then I've got -25 times -2. And that's 50 plus 50. And then -48. Okay. So G, the composition of G and F at -2 is equal to 70 minus 48. Okay, and then side work, we can show what that is. 70 minus 48. And we would borrow, and we would get 22, just like we did on the calculator, right? See what they do? There's your answer on the calculator, all right? Just by plugging these in, okay? And, but I don't care that it's faster on the calculator, because that would indicate that there was no value whatsoever to learning how to actually compose functions using paper and pencil. You know, now if that was a STAR test question, I would certainly teach the calculator method, but you know, in an upper level mathematics class, they just have, the calculators have no place at all, none whatsoever, except for trigonometry, right? Okay, so excellent. And that's number 1. All right, now moving on. Given the definitions of f of x and g of x below, find the value of g of f of 3. So again, it's g of f. That's the first step. Compose g and f in that order. G of f of x, okay? So I'm going to show you this notation again to get you comfortable with it. The composition of G and F, okay, at X, right? So right now we're just composing these functions at X equals, and now what I'm going to do is, so I'm going to kind of write out the skeleton of G of X, but leave a big, huge hole here so I can stick this in there, okay? Because I'm going to place this entire quadratic in where this x goes. But let me show you an intermediate step so you don't get confused. We have negative, open parentheses, close parentheses, minus 8. And what we're going to put in there is f of x, okay? Whatever that is, okay? So that's what I'm sticking in that space. Well, f of x is 3x squared minus 5x minus 6. So we will put new equal signs, negative, open parentheses. And this time I'm going to write 3x squared minus 5x minus 6. And then at the end of that, we have to remember to put minus 8 because that's part of the original function. In fact, it might be helpful for me to put the original function in blue. Okay. And then the thing that I'm putting in there in red. Okay, so you see what I'm doing? And now we're going to need to distribute this negative symbol. So it might be helpful, and I think it always is helpful, to remember that that's really a negative 1, and you're multiplying a negative 1 to each of these terms inside the parentheses, which just has the effect of changing the sign. But still, we'll do it. So we have here, it'll just change the sign. So it'll be negative 3x squared plus 5x plus 6. Okay? Negative 3x squared plus 5x plus 6 minus 8. Okay, and now we just need to take 6 minus 8, which is negative 2, and we'll get our final composition there. So here we can say, again, I'll use yet a different notation here for you. G of f of x, again, identical to this, same thing, equals negative 3x squared plus 5x plus 6, pardon me, minus, not plus 6, negative 3x squared plus 5x minus 2. Okay? Perfect. All right, so now, so again, that's this moment right here is what you'll never see if you do it on the calculator. You'll never actually find out what the composed function is. So you can't do anything with it. You know, you're limited with using the trick of playing with the calculator. You're limited to just evaluating it. You never get to see the actual function, which is kind of the whole point. So now we can evaluate this composed function at any number we want, and they want us to do it at 3. So now we're going to say the composition of G and F. Okay, I'm using this different notation again. Again, I'm switching back and forth between notation styles just to get you comfortable that they are interchangeable and identical. So now we're evaluating this at 3. And so again, this time I'm going to replace these x's with 3's. So we'll put our -3 and then open and close parentheses squared plus 5, open and close parentheses, minus 2. Okay, and I'm going to put that 3 in there. Okay, so this is what I'm evaluating. All right, so let's see what happens. Well, 3 times 3 is 9, and 9 times -3 is -27. Now 5 times 3 is 15, so plus 15. Minus 2. Okay? So let's just work from left to right. I say 27 minus 15. Get some side work here. At 27 minus 15, the result's going to be negative. 7 minus 5 is 2, and then 1, and it's negative. So I have -12 minus 2. Okay, and that's going to be -14. So G of F of 3 is -14. All right, and that is the red box answer. Okay, moving on to number 3. And they're using the notation that I was showing you before. Again, it's just the same. It's G of F of -2, G of F of X. Compose those functions and then evaluate at -2. Okay? So let's get after it here. So we got G, the composition of G and F at X first. And so that'll be 3, open parentheses, and then I'll put in here -4x minus 9. -4x minus 9 squared. So we're going to be squaring this binomial here. And then we have -6, open parentheses, -4x minus 9. And -12. Okay. 12 looks like a 72. Okay. So the hardest part computationally here is going to be expanding that binomial. Okay. So we may want to do that kind of off to the side in its own little world. Like we'll make a little work area here where we're going to go ahead and expand this binomial. So what you're really doing here, just in case that you forgot, it's negative 4x minus 9, and you're squaring it. Okay, so you're multiplying it by itself. Negative 4x minus 9. And it's first, outer, inner, last. F-O-I-L. F-O-I-L. FOIL. Well, first times first. So what is that? First times first. That's negative 4x times negative 4x. Okay, so let's take the numbers first. Negative 4 times negative 4 is positive 16. X times x is x squared. Okay. Outer, negative 4x times negative 9, positive 36x. Okay. Inner, negative 9 times negative 4x. That's going to be positive 36x. And then last, negative 9 times negative 9, positive 81. Okay. These middle terms always combine, and 36 times 2 is 72. So this is going to equal 16x squared plus 72x plus 81. All right, and so that was, I think, a good idea to carve out and do separately. So now we're gonna, when we come back down, we will just stick that into where this was. Okay, so we've squared it, so it's just going to be 3 times, and then we'll put this in parentheses. So we're going to bring down this here. So we have G, the composition of G and F at X equals 3, open parentheses, and then 16x squared. That's what we just did, plus 72x plus 81. We already squared it, so now minus 6, open parentheses, negative 4x minus 9. Minus 12. Okay, so 3 times 16, that's 30 plus 18, 48. Okay, so this is equal to 48x squared. 3 times 72, that's 6 plus 210, 216. Is that right? Make sure I'm right. Yep. 216x. And then 3 times 81 would be 243. All right. 81 times 3. Yeah. Plus 243. Okay. And now we're essentially multiplying this -6 to these terms here. Okay. So -6 times -4x is positive 24x plus 24x. And then -6 times -9 is plus 54 minus 12. All right, so now our life is just a matter of combining like terms. There are no other squared terms, but this 216x, this 24x go together. So 16 plus 24, 24, they got 34, 40. So 240. So let's write 48x squared plus 240x. Just check that again. I got 16 plus 24. Yeah. Okay. And plus, now we've got to add up 243 plus 54. So 243 plus 54. All right. And that's going to be 7, 9, and 2. And then subtract 12. And that would give me 5, 8, 2. So we have plus 285. Okay, so that is the composed function. That is g of f of x. Okay, and so now they want us to evaluate that at -2. Okay, so we'll say g of f of -2. Okay, so we're going to write 48, open and close parentheses, squared, plus 240, open and close parentheses, plus 285. And inside those parentheses, we're going to put -2 and -2. Okay. Well, you're looking here, I've got -2 squared, that's 4. And so I need 48 times 4. As you can kind of do it in your head. That's 40 times 4 is 160. 8 times 4 is 32. So it's like 192. But 48 times 4, I want to check because I could have just gotten that wrong. Doing that up here. So I got 2, carry the 3, 16 plus 3 is 19, 192. Okay, so we were right. And it's positive because when we square the negative, it became positive. So this is equal to 192. And then 240 times negative 2 is negative 480, right? Because you're 24 times 2 is 48, so minus 480 plus 285. Okay, so if we want to take 480 from 192, the way that we're going to have to do it is kind of like backwards. We're going to have to say, well, 480 minus 192 and I get an intermediate value of 288, and now we add, that's going to be negative 288, okay. And so now adding 285, what you're really doing is it's like you're subtracting 285 from 288, and what you end up with is negative 3. So this ends up being negative 3. So G, the composition of G and F at negative 2 is negative 3. And so to me, there are really two success stories in this problem. First is this, that you got this value. Great. But to me, I think this is the more important thing, that you were able to compose the two functions. I just don't, I cannot identify at all with a teacher that would, unless it was an accommodation special needs situation, in which case I have no issue at all. But if we're just talking about normal student saying, oh, just skip all this work, skip all that work, and the mental gymnastics and the exercise of the mind that you have to go through there, and just jump, in other words, get the answer as quickly as possible with as little work as possible, showing no work at all. I don't know what they call that, but that's, to me, I don't think that's a math class. I think that's a calculator class. Okay. All right, so we're moving on to number 4, and here we are again going to compose two functions, but this time we have the fog function, f of g of 1. So first we're going to do f of g of x, and then we'll evaluate that composed function at 1. Okay, so we're going to start by composing the two functions together, and this time we're going to compose f of g of x. So I call it the fog, like that. Okay. And we're going to essentially evaluate this at x. And here's what that looks like. So we're going to use this as our framework and stick in this in the big parentheses. So we start off with a big parentheses. And inside goes negative 4x minus 1. and then that value is squared. And then we have minus 6, open parentheses, negative 4x minus 1. And then minus 5. Okay, so again, here's this part here that we should probably do separately. Okay, so I've got negative 4x minus 1 times negative 4x minus 1 and I'm using FOIL, okay? F-O-I-L, FOIL. Okay, first times first, so take the numbers first. Negative 4 times negative 4, that's positive 16. And then x times x is x squared. Outer, negative 4x times negative 1 is plus 4x. Inner, negative 1 times negative 4x is plus 4x. And then last, negative 1 times negative 1 is plus 1. These inner terms always combine. So this will equal 16x squared plus 8x plus 1. Okay. And we didn't need as much space as I thought we would. And we can get back to the problem now. So moving on, we have gotten rid of the parentheses here. Now we just have 16x squared plus 8x plus 1. And now we need to multiply this negative 6, okay, to the terms here inside this parenthetical expression. Well, negative 6 times negative 4x is going to be plus 24x. And then negative 6 times negative 1 is plus 6. And then we minus 5. Okay. So we're going to clean this up a little bit. We got 16x squared. I've got an 8x and a 24x. And then that give me 32x, so plus 32x. And then I've got 1 plus 6, which is 7. And 7 minus 5 is 2. So plus 2. And that, my friends, is the step you would never get on the calculator. This is the composed f of g of x. Okay. Now we're going to evaluate that at 1. So f of g of 1 equals 16, open parentheses, space, close parentheses, squared, plus 32, open parentheses, close parentheses, plus 2. Now in this case, that's rather trivial, right? We're sticking in there a 1, but still good habit. Okay. So f of g of 1 equals 1 squared is 1 times 16 is 16, plus 32 plus 2. Okay, so 16 plus 32 is 48, plus 2 is 50. Let's just check again. 42 plus 6 is 48, plus 2 is 50. Yep, so final answer, f, I'm going to write it in a different way. F of g of 1, okay, identical to what I've been writing the whole time, equals 50. Okay. All right, so here's your blue box, the thing that you would never get if you cheated and used a calculator to do your work for you. Makes me want to throw up, honestly. Because what happens, guys, is you know, the teachers in the high schools, they want the scores to be high. They want the numbers to be good. They don't want parents to bother them. They want because the kids' grades to be good and blah, 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 blah. And the kids are, you know, teenagers are lazy and blah, blah, blah. And the math foundations aren't there anymore, so they really can't do this because they don't have the foundations. Many seniors, juniors, sophomores can't multiply, add, subtract, divide. They have trouble with negative numbers. When they see anything squared or quadratic equations, they act like they're lost forever. Now you can take this at its face, and you can do it what I see a lot, which is hand them the pacifier. Okay, and say, here you go, just use this. And yeah, the kid would be done with this assignment in 5 minutes. But when they get into college, if they have to take any math classes, you know, if we want to be competitive, and you kind of think one bell would be sufficient. But whatever. Yeah, if you get into college, that they won't let you use a calculator. So if you have to take the TSI, they won't let you use a calculator. So I don't understand why we would teach mathematics any other way. This isn't that hard, and it's not torture, and it's good for the mind. All right, so that's the answer to number 4. And we're moving on to number 5. Okay. It also builds up a certain amount of endurance in the mind of the student for them to sort of keep that whole process going in their mind. So now we're fogging here again. So f of g of x. So on number 5, we have f of g of x. So I'm going to use the f function as my skeleton and then put g of x where these x's are here. Okay, so I'm going to have 3 and then open parentheses and then negative x plus 1 close parentheses squared plus 6 open parentheses negative x plus 1 close parentheses plus 15. I think, with the calculators and the teachers that will defend their use, aside from the fact that I think those teachers are just giving up on the kids and failing to do their jobs, I think well, I should probably just keep my mouth shut about it. Okay, so we're going to have to evaluate this quadratic here. We're going to have to expand this binomial, and let's do that. We're going to carve out a little space here. Okay, so what we're going to do here is we're going to multiply negative x plus 1 by negative x plus 1. But I think what I was going to say is I think there is a misapprehension that the answer, the values that are in the red boxes, that was the point. Like the goal was to get 22 on number 1. And I disagree. I think the goal was to go through the whole go on the adventure to getting to 22. And it's almost, to me, it's almost irrelevant whether or not you reach 22 or not, but that you take the trip to 22. Okay. All right. So first, I think it's helpful when we have these called naked variables. We just put the ones in there. It helps us understand that what we're doing. So let's multiply the numbers first. So negative 1 times negative 1 is just 1. And x times x is x squared. We don't have to write the 1. We can just write x squared. And then remember the next letter for FOIL is outer. So negative 1x times 1 is negative x. And that would be the tardy bell. And then we have the inner, a positive 1 times negative 1x is negative x. And then we have 1 times 1 for last, which is plus 1. And the other thing I see is that it's really obvious to me that public schools in general, public high schools, they don't really care whether or not their kids are college ready. I mean, I understand as a teacher, right? I don't want parents screaming at me, right? I don't want kids failing, right? And then getting thrown out of athletics and having the coaches come and yell at me, right? So you just kind of bend to the will of your masters, right? And so to make your life less difficult, you just give the kids a machine and everybody's happy because the grades are good and the kids are getting the answers, and then they get out of here and they go into a college and they fall flat on their face. But guess what? You don't care because you're not there anymore. And that, I think we need, as high school teachers, we need to pretend as if we are sort of pre-college teachers. Okay, so now when I take negative 1 and negative 1, I get negative 2. So it's x squared minus 2x plus 1. And believe me, I've sat in on meetings where I was told that pre-AP Algebra 2 students could not handle this kind of mathematics without a machine. And I just burst out laughing. Because I could teach a seventh grader to handle this kind of mathematics without a machine. In fact, it would probably be a lot easier to teach a 7th grader to do this. All right, so now what we're going to do is plug this quadratic back in here without the squared symbol. So we need to distribute the 3, but we're going to put the parentheses around this. So we squared this, and now we got to do the distribution. So we got f of g of x equals 3, and then we're going to do this, x squared minus 2x plus 1. Okay, so that's going to happen, and then we're going to do plus 6 times negative x plus 1 plus 15 at the end. So that's our task. All right, so we're just going to distribute multiply this 3 through each of these terms here. And I think it's helpful whenever you see negatives, just put a grouping symbol there so you understand, hey, I'm going to be multiplying by a negative. Okay. And let's we'll go ahead and do both, right? So we'll distribute and multiply the 6 here and here. And then inside here I've got the negative 1x. So just keep that in mind. All right, we're going to perform, normally I would prefer to do one thing per line, but we're just distributing numbers. So all right, so 3 times x squared is 3x squared. Three times negative 2x is minus 6x. And 3 times 1 is plus 3. Now, we have 6 times negative 1x, and that's going to give us minus 6x. And 6 times 1 is plus 6. Plus 15. Okay, so now it's about combining like terms. So I've got this negative 6 here and this negative 6 here. And so I've got 3x squared minus 12x. And then I've got 3 plus 6 plus 15. So that's 9 plus 15, or 24. Plus 24. And there's that thing you would never get. There's your composed function. F, and then we'll do this f of g of x. Okay. Same thing as this. And now we're going to evaluate that at 5. Okay. So we'll say f of g the composition of f and g at 5. Okay, so the way I do this is I think 3 open parentheses, close parentheses, squared, minus 12, open parentheses, close parentheses, plus 24. And inside the parentheses, I'm going to put a 5. Okay. All right, let's see what we get. Well, 5 squared is 25. 25 times 3 is 75. So that's 75 minus 60, because 12 times 5 is 60. And then we have the negative. So minus 60. So right now we're at 15 plus 24. So 15 plus 24, right? 75 minus 60 is 15. And then plus 24. So that would be 15, 25, 35, 39, right? Let's just make sure we're not making some stupid mistake. 15 plus 24, 39. Okay, good. All right, so the final answer, we have F, the composition of F and G at 5 is 39. Okay. So there's your answer. And here is your composed function. All right, here we are at number 6. And so this time we're doing f of g of x again. So that's fog, and evaluating it at -3. All right, so to get started here, we'll compose f of g of x. And that means we're going to use this as a template and then put -x minus 4 everywhere we see an x. So we have 3, and then open parentheses, -x minus 4. Close parentheses, squared, minus 7, open parentheses, -x minus 4, close parentheses, and then tack on the minus 3 at the end. Okay, and so there's the task before us. And like always, we have this quadratic thing to square. Okay, so we're going to multiply -x minus 4 times itself. -x minus 4 times negative x minus 4. Okay, and so first outer inner last. Remember, we can put a 1 in here to help you remember what to do. So negative 1 times negative 1 is positive 1, and x times x is x squared. So this is x squared. Outer, negative 1x times negative 4 is plus 4x. And inner, we have the same thing. Negative 4 times negative 1x is plus 4x. And then negative 4 last. Negative 4 times negative 4 is plus 16. Combining the middle terms, we get our final simplified quadratic expression. X squared plus 8x plus 16. Okay, and so we're going to put that back there. And that'll close off this here. Okay, so now we have f of g of x equals 3, and then inside this parentheses we're going to put this quadratic, x squared plus 8x plus 16. And then we have the rest of the minus 7, open parentheses, negative x minus 4, close parentheses, minus 3. Okay, so now let's get to distributing here. So we're going to distribute this 3 to each of these terms. And we're going to distribute this negative 7 to each of these two terms. And inside of here, I've got this negative 1, and I've got a negative 4. Okay, so negative 1x and negative 4. So let's be careful when we get over there. So we have equals, well, 3 times x squared is 3x squared. 3 times 8x is plus 24x. And 3 times 16 is plus 48. Now, negative 7 times negative x is plus 7x. Negative 7 times negative 4 is plus 28. And minus 3. Okay. So there are terms that are like, we can combine. I've got 24x here and 7x here. So that would give me 31x. So let's see here. I got 3x squared plus 31x. And then 48 plus 28, that's going to be 16 plus 60, would be 78. Minus 3 would be 75. So plus 75. I want to make sure I did that math right. 48 plus 28, 16, 76. My bad. I think I said 78. See, that's why we check. 76, and then 76 minus 3 would be 73. Okay, plus 73. All right, that's why we always double check mental math. Okay, so that's the composed function. So we'll write f of g of x, and there's your composed function. And now we can evaluate that. They want us to evaluate it at -3, so we can say, okay, now f of g of -3 equals 3, and then leave your space, squared plus 31 plus 73. Okay, and what are we evaluating? -3. -3. Okay. Well, -3 squared is 9 times 3 is 27. And then I've got 31 times -3, which would be -93. Plus 73. Okay, so in side work, first let's double check over here that 31 times 3 is really 93. Yep. And then in side work here, what we're going to do is we're going to take 93 minus 27 and then make the answer negative. Okay? So that'll give me 66, -66, plus 73. So now I'm going to do 73 minus 66. And the answer will be positive. And the answer is 7. Does that make sense? Yep, it does make sense. So this whole thing evaluates to be 7. Okay, so f of g of -3 is 7. Okay, so put that in a box. And then here's your composed function. All right. Number 7. Express your answer as a polynomial in standard form. Okay. That just means ordered by degree. G of f of x. Okay. So what's nice about this problem is this problem here exposes why you should not teach the calculator method, because it's not asking you to find an integer value. It's just asking you to compose the function. which we've been doing the entire time. So g of f of x. So here we're going to use g as our skeleton. So this is going to equal open parentheses and then 2x squared. We don't even need the parentheses. We're just going to write 2x squared plus 2x plus 2 plus 7. And the only thing we have to do here is add 2 and 7. So g of f of x is equal to 2x squared plus 2x plus 9. And that's it. That was a quick problem. Moving on to number 8. Express your answer as a polynomial in standard form. Find g of f of x. Okay, hopefully they give us more to do here. Okay, so g of f of x. So there's more to do here because we're going to have to square something. So here I've got open parentheses negative 3x plus 5 squared plus 4 open parentheses negative 3x plus 5 minus 15. All right, so we're going to carve out our little space here for doing this FOIL. We have negative 3x plus 5 times negative 3x plus 5. And we're going to use FOIL, okay? First, outer, inner, last, FOIL, okay? Let's do the numbers first. So negative 3 times negative 3 is positive 9. X times x is x squared. Outer, negative 3x times 5 is negative 15x. Inner, we have the same thing. Negative 5 times negative 3x is negative 15x. Last is 5 times 5, it's just 25. Plus 25. And then we combine the middle terms. We have 9x squared minus 30x plus 25. Okay, so going back to the problem, let's we'll say g of f of x is equal to 9x squared, we don't need any parentheses anymore, 9x squared minus 30x plus 25. And now we are going to put plus 4 times negative 3x plus 5 minus 15. Sorry. Okay, so our task is to distribute this 4, and then just remember that's a negative 3x right there. We're going to distribute here and distribute to that 5 right there. All right, so we have 9x squared minus 30x plus 25. And then 4 times negative 3x is negative 12x. And 4 times 5 is 20. And then we put minus 15 at the end. Now they want us to combine like terms. I got negative 30x and negative 12x. So that'll be negative 42x. So this will give me 9x squared minus 42x. And then I have 25 plus 20, which is 45, minus 15, which is 30. So plus 30. Okay. And that is the composed function, g of f of x. Okay. All right, now for the final two problems, we kind of switch gears a little bit and we evaluate graphically. So let me show you what we're doing here. So what we're doing here is we're going to look for the graph of f of x, okay? This one. And we're going to go to negative 4 on the x, and we're going to draw a line up to where it hits the curve, then hang a right and go to the y-axis. This is kind of what the trick they're doing with them when they're playing with the calculators. And what is that value right there? That value right there, okay, you could say f of negative 4 equals 3, okay? So that's 3. And then what do you do now? Well, you plug that in over here, right? So now you go over here and find 3. That's right here in between 2 and 4. And we go up to the curve, and then we hang a left in this case and go to the y-axis over here. And what value is that? Well, that value, you could say g of 3 equals 5. Okay, but you could also say, equivalently, you could say down here, you could say g of f of negative 4 equals 5. So you've kind of, this is actually what's kind of happening with the calculator trick, okay? Of course, when it's graphical like this, that's fine. That's kind of the whole point, right? To learn this using the using pictures, but the hand-based algebra is what isn't being taught in schools sufficiently anymore. All right, so moving on. Evaluate number 10, f of g of 2. Okay, so first thing we're going to do is go to the g graph that's here. And we're going to look at 2. So there's 2. And I'm going down to the curve. Then I'm going to hang a left. Okay, and I see -6. And so I can say, all right, what's going on right there at -6? I can say g of 2 equals -6. Okay? Well, now I want f of g of 2. So now I want to go to -6 on my f graph. We'll go to -6 down to the curve, hang a left, and go over to the y-axis. And we see -3. And so there's two ways to say this. You could say that f of -6 say f of -6 equals -3. Or you could say f of g of 2 equals -3. Okay, because that's the final value. I guess I should circle that right up here as well. Okay, and that's pretty much, that's pretty much it. All right, well, that brings us to the end of the composition of functions video. Thank you so much for watching. That was a journey, quite a journey. I always like to take a look at the work that we did. All right, beautiful. Well, listen, thank you so much for watching. Please make sure to like, subscribe, comment, hit the notification bell so you're always alerted when I release new videos. Thanks for watching.